Geographers also needed some way to account for the creation of mountains in the first place.
At the start of the 20th century, a number of Earth geophysical phenomena, such as earthquakes, including the 1906 tremor that devastated San Francisco, and volcanic eruptions, also puzzled geographers. Surprisingly, these phenomena would be brought together under one umbrella theory 60 years later.
Abraham Ortelius, a 16th century Flemish cartographer, a person we geographers recognize as the creator of the first modern atlas, noticed the similarities between Africa's west coast and South America's east coast. It was easy to imagine South America's bulge fitting into West Africa's indentation like pieces of a jigsaw puzzle. Trying to make sense of this observation, Ortelius asked the geographical question, could they have been joined sometime in the distant past?
At the same time, maps also helped to show that earthquakes and volcanoes occurred in specific regions on the planet, regions often associated with mountains. Were all these phenomena related? In 1912, the German physical geographer Alfred Wegener, in an attempt to answer Ortelius's question, proposed that all the continents were once joined into one giant continent called Pangaea. Then, over vast geological time, they had drifted into their present-day positions. This meant that the outer layer of the planet, the crust, had to be cut into large movable plates. Plate tectonics, as it was called, required that geography totally reshape its explanations of Earth processes.
Plate tectonics was such a revolutionary change in how we viewed landform processes and the evolution of the Earth's surface that it forced geomorphologists, as well as all of the geological sciences, to rethink how the Earth functions. It meant a revision of some long-standing thought. It is perhaps can be likened to a Kuhnian revolution in the sciences, that the normative science had to be put aside and a new set of ideas had to be adopted.
This idea of continental drift initially received little early support, but eventually it explained the San Francisco earthquake. It was the result of the North American and Pacific Ocean plates sliding against each other. And indeed, Ortelius was right. Africa and South America were once joined. We can now see in retrospect that by the middle of the 19th century, geographers were well on their way to understanding that the forces that shape the planet's landscapes are the same forces occurring today.